Welcome to Manufacturing Mavericks, a podcast where we showcase and celebrate exceptional people from across precision manufacturing who are boldly embracing new ways to improve their processes, grow their bottom lines, and ensure American manufacturing will thrive for generations to come. Welcome to this episode of Manufacturing Mavericks. I'm your host, Greg McHale, founder and CEO of Datanomix, and I am thrilled to be joined today by Rebekah Collogan from Phoenix Meccano. How are you today, Rebekah?
I am well, thank you.
I really appreciate having you on, Rebekah. I know we've gotten to know each other over the last couple of years, and I know you are deeply involved in many different aspects of manufacturing operations, business data, machine data. So I'm really looking forward to seeing what topics we get to dive into today.
Yeah, sounds good. Me too.
Awesome. So Rebekah, just to break the ice on Manufacturing Mavericks, the way that we typically get started is I love hearing about the origin story of how everyone gets into their own manufacturing journey. So how about we start with how and when did the manufacturing torch get lit for you?
I was thinking about this, and I usually say in college, but I really think it started when I was a kid. I grew up on a farm in Kansas, and my dad had a wood shop. And so every night he'd go out to the wood shop. He was a CPA by day, still is, and a farmer, weekends and evenings, and then would also make the furniture for our house for my mom. And so I'd go out to the wood shop with him, and I'd hold the board on the other side of the planer. I love the smell of wood chips. And I think, I was one of four kids, and I think I was the only one that really just rain, snow, didn't matter. I was out there in the shop with my dad, and I just loved seeing these things come together and being part of that process. And then when I was in college, after I finished my degree, or in the last year, I did a degree in industrial engineering. And in my last year, I did an internship at a manufacturing plant just to, have some experience. I hadn't planned to stay in manufacturing. And then I caught the bug. I couldn't shake it. I loved seeing change and transformation and changing people's jobs and how they were able to do their work, as well as the product changing as it went through the process. It's just, you get the bug and you can't shake it. So yeah, for me, it was probably a combination of those two.
Do you still have any of the furniture from Dad still in the family?
I have a few things. My dad precision is just not his strength. And so it was made out of love, but not for longevity. I'll say that.
Got it. So really more of for the coffee table book than for the coffee itself.
Exactly. I think my mom still has the furniture. She wouldn't give it up, so I don't have any of it.
And I mean, as you were describing the smell of wood chips, who doesn't like the smell of freshly cut wood? It's so good. So college, industrial engineering, you start getting drawn to process optimization, problem solving, getting out there into internships and whatnot. What were some of your first jobs and career positions?
I was a manufacturing engineer at a plant that made skid steers, and which, if you don't know what that is, it's essentially a Bobcat is a version of skid steer. It wasn't that brand, and one of my first projects after a couple of years in there was a clean sheet design of the skid steers, managing that project. And I was responsible for the manufacturing launch side. It was a project I had no business, honestly, being responsible for at that stage in my career. But, when you're given opportunities, you take them. And so I took it, and it was a massive project. There was another individual that managed it was an all new weld line with robotics and press brake and everything done by an outside integrator. And then my responsibility was the project management and assembly line setup process, validating the design, making sure everything's manufacturable. And I learned a lot during that process about failure, what not to do, and all the wisdom I have now is from doing the wrong things all along the way. And so that was my first, I'll say, big project and position that just had a great trajectory, I'll say, for the rest of my career. Good experience.
So, I mean, a skid steer end to end from clean sheet, that's literally the scope of the project.
Take the existing design, throw it away. And the concept was all new design in 18 months. We weren't successful in 18 months, which thank goodness. We took the time for testing and validation after that. But the idea was parallel design, testing, and manufacturing. And it was aggressive.
How much of the manufacturing of that was in-source versus outsource for that project?
The base, the frame was welded and cab was welded inside. The tub of the chassis was bent. The large plate was bent, and there wasn't at this point. So I mentioned previously, I'm doing research on nearshoring and manufacturing and the impact of the pandemic. And part of the reason why I'm doing research into that is because when I started my career in the early 2000s, I was working at this manufacturing plant that had outsourced a bunch of their manufacturing. The plant that I was working at had previously done, hydraulic tube bending and had lasers and did all the plate work, cutting plate work there, and had built cylinders, even hydraulic cylinders. And by the time I arrived, all of that work had been outsourced to competency centers or locations in other countries or other facilities. And really manufacturing was going horizontal at that point. And we felt the impact of that during this product launch where you were trying to make small changes to components that were made in other countries or in other states or facilities, and the effort it required to get those changes implemented and then new product into the door was significant. And so a lot of the product was made outside, but certainly all the welding of the chassis and cab and arm were done inside, and then it ran through a paint line and then full assembly. But it was definitely different than the previous generations.
With something that complex and in-sourced components, outsourced components, things wildly out of your control as part of that process, how do you even begin to manage all of that? That sounds like a lot of potential chaos.
It is chaos, documentation of, okay, this tube in this location, it worked in the model, I'm married, and I can say this, I'm married to a mechanical engineer. He's on the design side, I'm on the manufacturing side. Well, it worked in the model, why doesn't it work in reality? And so, change the tube a few degrees bend, or you can route that tube in the model fine, but once the engine's installed, there's no way we're going to get the tube underneath there, and you have to put a split in here. And so it just trying to document all of these changes while testing's happening in parallel to product design, in parallel to, we're designing tools for the weld system at the same time that the product's being validated. And so it was chaos, but it was, at the same time, it was kind of fun.
I can tell by just hearing how you're talking about it that you definitely felt rewarded in driving the complexity to ground and ultimately in producing the product, right?
Yeah. It was a challenge, and a challenge that I didn't think was possible, but we were successful in the end in launching the product into reality. That's manufacturing, right?
That's it. I mean, you said you caught the bug. You weren't kidding. You have to have the bug to stay on top of projects like that on crazy timelines and keep pushing it through. And what I was going to say is I actually learned what a skid steer was when my kids were babies, and I would read the little truck books to them. So
we have a filtering process. If they don't call the equipment the right name, then that book is out. We're out. If you call it a Bobcat, get out of here.
Yeah, that's like saying Kleenex, right?
Right.
Awesome. And so now you're part of, you're vice president of operations at Phoenix Meccano North America. Why don't you tell us a little bit about Phoenix Meccano?
So we are a solutions developer. Essentially, we help end customers. Our customers are in oil and gas. They're in the energy sector. They are in the medical sector. We help develop solutions for electronics and electrical applications where anything that needs any sort of electrical equipment that's out in an environment needs to be protected in some way. And so we help provide that protection by developing enclosure solutions for them. And that can be as simple as just providing the housing and they do the value added work to it. But here, our focus is really to help our customers have good solutions for their product in that we offer machining to make it easier for them. We'll do paint, powder coats. We'll customize our catalog of standard enclosures made by our company globally for whatever application the customers need. And so I have a team of design, manufacturing, quality engineers that will support, problem solving for our customers. We also have another product line that is for more on the automation solution side of the business. And so we'll develop workstations or we'll integrate linears or lifts into, we'll do the platforms and staircases. We'll design those for customers to integrate into their equipment, machine design. And so really we're kind of at the front end of the supply chain where customers are looking to put their products inside of their products. What we say is that we try to simplify the process so that the customer can focus on the big picture. Our solutions are simple. We try to make it easy for the customers to do business with us.
Got it. So is the right way to think about Phoenix Meccano as effectively an OEM with a pretty broad catalog, but that also needs to support, it sounds like, some fairly unique customization in the purchasing process?
Our catalog is quite broad and the applications are also quite broad. So we have engineers that need to be able to understand. We work in the oil and gas sector, and so they need to be able to understand ATEX and ICEX regulations and those impacts and how our products are used safely in those industries. And then we also need to understand how to integrate a lift into a multi-axis system and be able to support the customers and controls and understand how our lifting system will impact their overall control system. And so and then we also have customers that just need a hole in a box for a prototype part. And 10 to 15% of our production orders can be fewer than 10 pieces, 1 or 2, 3 pieces. And then we'll have customers that will order regularly, but we have a wide variety. We trade with 200 to 2,500 customers annually.
Wow. So I know you've been with the company about a handful of years now, Rebekah, and obviously have made many technology investments along the way. What did the process look like to support that kind of business when you first joined, and what does it look like now?
Yeah, I think you're referencing our machine investment, right? In the last couple of years, we've invested in all new machining centers in our production area to be able to respond to changing workforce needs. We're in an area of the country that is, we're along the I-95 corridor, which is great for our customer base. It's a very up and down I-95. There's a lot of electronics and electrical integrators, but our specific location is far more medical and biomedical research. We're just outside DC. And so there are fewer just heavy industrial manufacturers here. So the workforce in this area is far more just not the skill set that we need for machining. So we had 13 different machining centers previously of all different vintages from the late 60s all the way to the mid 2000s. And we just in 2 years got rid of all of them, replaced them all, and went with one machining center, one type of machine, and standardized that to be able to offer standard controls to our operators so that the interface is the same. When one operator goes from one machine to another, then they know how to operate all the machines. That's really what drove it for us, is to be able to reduce our setups, standardize our setups, standardize operator training, and be able to, in some ways, standardize our programs so that, offsets are a little different between the machines, but to have standards established, we have so much variability in our product line that to have the variability in the product line and the machines and the controls and the setup approach, it was just too complex. I mean, if you've worked in manufacturing for any length of time, you know that there's just variability everywhere from all directions. So our effort was to try to remove some of that variability and standardize it so that our operators could be more successful, so that our setup times could be reduced. And we see the effect of it. It's been a great investment. And at the same time, we invested in Datanomix, and we gave that feedback to the operators so that they could better understand how their decisions, their day-to-day decisions, and how they interface with the machines impacts the productivity through the line. And so, yeah, that's one of the biggest investments that we've made, and we've seen great return on it.
So 13 different machining types down to one is a heck of a consolidation. That sounds pretty disruptive.
Yeah, we have 6 machines today and are getting more output from the 6 machines than we were from 30 to 40% utilization on 13 machines. So
that's fantastic. Reducing the complexity for the operators, and then based on the catalog of parts that you offer, and then it sounds like there's a lot of potentially little tweaks. I'm guessing a pretty significant number of SKUs as well that gets serviced across this now one machine platform.
If we have 2,500 customers, we usually have around 2,500 or more part numbers, probably 3,000 or 4,000 part numbers annually. So yeah, every customer has their own, and then several customers have multiple part numbers. So. And it could be a profile, a piece of extruded profile running through the machine, or it could be a plastic housing, or we have fiberglass enclosures for special applications like EX, just all kinds of different materials, stainless steel, plastic. So it could be any of those in any shape.
So you talked also about sort of consolidating, optimizing the setup workflows as part of that change too. I mean, with all that variation that you just talked about, number of SKUs, materials, slight variances effectively in the features of what gets produced, what did that process look like to get those setups tightened up?
We had some standard fixtures for our housings, but we built on that by standardizing how the parts are in every machine. And so the machine that we bought allows us to have a table as well as a 5-axis and be able to set up all the parts in the same way. Most of our parts are just in the shape of a 6-sided box, and so we're able to standardize how the parts are in the machine using the standard fixture. But then beyond that, we've really started to build standard fixtures for the weird shaped parts. Not all housings are 6-sided boxes, so we located where the boxes were and set the vices on the table and the 5th axis in the same place on every machine. And really, it's hard to describe it in words. We built the extension for the box, customized them for the machine. So every machine has its own version of the setup tools to be able to put the box in the same location so that the programs can be standard. And we only have to change the offsets in each program by machine.
I know from, the results that you were talking about previously, if you go from 13 machines to 6, increase the output and also service that much additional variance on a reduced footprint, that there had to be some pretty significant engineering optimization, machine optimization to be able to pull that off. So really awesome to hear about the layers of complexity that used to be there, and then how to get it down to something that, particularly when you talk about the workforce aspect of it, right? Talk about levers of automation that you've really introduced into this process. Is you didn't just go to a robot, you actually unwound what sounds like half a dozen or more layers of the problem to get to something that's much easier to make repeatable.
I would say I'm not satisfied with where we are. I still think there, with all the with all the improvement we made, there's still more.
There's that bug you caught.
Oh man. There's just so many more improvements that you could walk out to our shop and still see more opportunities. And the improvements that we made were great, and the shop runs much better than it did previously. And also, we shouldn't stop. We should continue. And I still think there's opportunity to improve how we hold the parts, how many we can fit in there. You mentioned robotics and automation, and we're starting with that. Just more and more opportunities. I think we can't slow down and stop.
Love the attitude. In that regard, what investments are you looking at in the next 12 to 24 months? Where does the next layer of optimization come from?
There's automation at the machine. There's integration of robots and working with the operators, our existing operators, to support them better and doing some of the repetitive tasks that they don't need to do, that they can help in other ways. So we're starting with those. But I think a big piece for us is systems integration. Yes, we need to work on making the parts faster and better, but for every individual in production, there are 2 or 3 more outside of production that are supporting that function. And so for us, it's the whole system, the entire process, and how I mentioned it earlier, but how easy it is to do business with us, how easy it is to get a quote, to get a part started and out through production. The time on the machine is just such a small fraction of the total time and effort that all of us put into making the parts. And our investments are really in the future more on the systems integration side, getting our ERP more closely tied in with all the other systems. It already is. I mean, we live and die by our ERP system, but also with our visual work instructions, with our sales and operational planning, and with our forecasting, and using more technology to understand where the market is going, and reading our inventory levels, all of those things, how the customer receives a quote, how we run that new product, every new item through our system, and whether we can automate pieces of those steps. That's where we're investing, yes, in manufacturing, but in the whole process of manufacturing.
Sure. I mean, I think you call upon a fantastic point, which is obviously the time in the machines is one of the big things that draws all of our attention. And by the way, I don't always do this live on episodes, but I had to go look at some of your continuous improvement data. I have to give you a ton of credit. Your utilization's up 19%, 19.7% year over year. That's the rate of change. So you guys have picked up almost 20% in the last 12 months. And your downtime is actually down 24% just in the last 6 months, which is some pretty incredible improvements.
I'll let my team know, but they can't rest. It's not time to sit down.
Those are good numbers, but they're not good enough.
We've not arrived.
Right? Always happy, never satisfied.
Yeah.
Good job, guys. Where's the next 20%? No, but so that's the in-machine stuff, right? So a lot of good things happening there. But I think you calling attention to the outside of the machine and the human interaction, looking for information, having the right information, knowing what to do. How do you try to get better insight and better tracking on some of those dimensions?
We do track failures. We track engineering failures. We track production failures, obviously. We track internal failures, and we really work to drive some of the root cause. I have a stack of 8Ds on my desk. My team would say I'm a little too particular, but I really think that if we put the effort into finding what truly happened at the failure, then it's easier for us in the long run. And so we try to make those improvements through identifying what went wrong, and then also just looking at, we have dashboards that we use Power BI quite a bit with our ERP data and some of our CRM data. And I measure how long it takes for us to get a quote to a customer. And then we set targets and identify projects to make improvements to that time, because a lot of people offer housings and solutions, and I like to believe that one of the advantages is the quality of our product and our ability to respond to what customers need. But I also know that effort is always a factor. When we go buy something, if it's really difficult to work with that company, then I'm probably not going back to them. And so I know that our customers have the same perception. So I think measuring the things that matter to our customers and identifying projects to improve those and just continually chipping away at it. I'm not looking to make significant improvements to the overall operation in one fell swoop. I'm looking to make measured small improvements day after day, year over year.
That is so well stated, Rebekah. I know we were joking a little before we got on the air about sometimes manufacturers get lost in the weeds of tracking fractions of hours on their people. So, I mean, you're talking about really instrumenting parts of the process that I'll say, I don't know that it's necessarily obvious or easy to a lot of people in the industry to know how to instrument and measure the types of things that you're talking about. I mean, how do you do that?
We live and die by our ERP system, and in the last couple of years, I added a manufacturing systems integration engineer who's now a lead in the area. And so we had a reset of our whole system a few years ago. And after we were forced to do that, we, as a company, we just couldn't stop with all of our systems integration and process improvements. And so once we started doing that, and if your house burns down and you rebuild it, you're not going to rebuild it the same way. So once we started rebuilding our system, we rebuilt it in a way that we wanted to. And the team here is very collaborative and interested in making things better, for everyone internally and externally. It's a great environment. And I think that part of it is the systems engineer that is building these dashboards using the data from our ERP system and linking it together. I mean, Power BI has been a great tool for us to learn and be able to quantify a lot of those things. And then obviously also Datanomix with the dashboard that we have in production, to just data everywhere, but useful data. And we try to pull it and simplify it. I think the challenge of Power BI, and honestly at times Datanomix, is there's so much information. What of it is important to us? And so that's really our challenge, is not how do we get the data, but which pieces are we going to drive and which ones are important to us. And we have a lot of discussion about it, and sometimes we change and we pivot after we start measuring it for a period of time, but that's our challenge.
If I understand correctly, it sounds like, in terms of getting insight into some of these other dimensions of what I'll call analytics, like time for quote to customer and these other metrics around different pieces of the process that are outside of the core manufacturing itself, it sounds to me like, rather than trying to say like, hey, we have to burden everybody out there at every step with tracking, and creating data, you invested in a skill set that had the ability to basically look in and across your data systems in this integrations engineer function. And basically, when you rebuilt, started with the idea of, we're going to connect every data point, we're going to measure everything from point A to point B to point C based on the data we have, and we've got to make sure that just the default way that we operate creates the data that we need to do these kinds of analysis. Does that about sum it up?
You said it much better and more concisely than I did. Absolutely.
It's my job to summarize and make sure that I understand. I wasn't sure that I had it right, because that's a super unique angle, right? A lot of people think, oh man, for me to get that data, I got to go get 25 people doing this, right? I got to go get 10 people doing that. And you sort of came at it completely the other way, which is like, no, I just need that to be in my data. and it's already there. And if I can get someone who can connect those things, which is what probably didn't happen naturally on its own, which is why, that function is something that you ended up investing in. If you could get someone to connect those dots, then you've got the information that you need. It's not like it wasn't there. It's just it needed to be strung together.
Yeah, and it has to be data that you can trust too. I have talked to other manufacturers who say their ERP is about 80% accurate or 60%. And if your bill of material is not correct, then the challenges that you have, this isn't even a topic. Systems integration isn't even a topic. I really think that having good data to begin with, and then, in my opinion, connecting those dots is way easier if you can trust what you're getting to begin with.
Sure. And I mean, I think I know you and I, Rebekah, have talked in the past about, I think you have the highest trust and most accurate ERP data of anyone I've ever met. The gap between 80% and 100% is 100 miles.
Yeah, even if the engineers, do we really have to update it? Yes, 100%.
I think you've covered all the different dimensions of this so nicely. I mean, this has been a master's class for me in operational excellence, literally starting with something that you worked on so complex at the very beginning of your career. And really, I mean, the only way to survive and succeed at a project of that magnitude and scope is probably to have the good information well organized.
I said all my failures are my pearls of wisdom today.
Yeah. So, I mean, that dovetails very nicely into then, in your current capacity, dividing the number of machines by more than half and increasing throughput significantly, but also standardization, repeatability, capability, capacity. I mean, all those dimensions are outputs of all the simplification that was done. And then again, I've seen some of the things that you and your team do with Power BI and the analytics you have on different dimensions of the process. And I know it's quite amazing stuff. And so it was awesome to hear really how you got there and what went into that. And I think really for the audience to hear how investments in data-oriented skills can really make a big difference in what the business knows and what it knows how to do. And obviously there's your core technologies that you choose, the vendors that you partner with, but also just saying it's a core competence that we know what our data means every single day on everything that matters to how our customers become satisfied.
Yeah, absolutely.
So Rebekah, I deeply appreciate that master's class. I'll brush up on my 8Ds for the next time that we speak.
I want to know what really happened. You got to dig, Greg.
You got to dig. Yeah. I'm good at that. Sometimes at digging myself, but that's a different problem. So Rebekah, what we like to do to end the episode is ask a little bit of an existential question, which is if you could go back in time and talk to the version of yourself that was there when the manufacturing torch just got lit, which in your case is so nice to picture. A young Rebekah in the wood shop with dad making crooked-ish furniture. It's just a design element, right? It doesn't need to be precise. And you could tap her on the shoulder and whisper in her ear and give her some great piece of advice. What would you say?
I think I would tell myself not to hesitate. I think that I wasn't sure about whether or not this was for me. And I think I would say, no, just keep going. Don't hesitate. You don't have to look right or left. Keep going.
Just do it.
Do it.
Do it. Love it. Take on those complexities head on, and you end up being...
Yeah, maybe not everybody's doing what you're doing, but that's okay. Keep going.
Right. You don't end up as the highest confidence person with 100% accurate ERP data by waiting, that's for sure.
It's not just me. Everybody here contributes to that.
Incredible. Well, thank you so much, Rebekah. It has been a joy to speak with you, to continue to learn from you, and I'm confident that the listeners will enjoy this master's class as well. So thank you very much.
Thank you. Appreciate the time.
Thank you for listening to Manufacturing Mavericks. If you'd like to learn more, listen to past episodes, or nominate a future Maverick to be on our show, visit mfgmavericks.com. And don't forget to subscribe to and rate this podcast on iTunes, Spotify, Google Play, or your favorite podcast app.